G'day, my name's Rouse, and today I want to show you how to make an audio occlusion script using Bolt for Unity. So, first things first, so I've made like a little scene here, which you can see down here, which is essentially a little level. I've got a cube, and this is the player, and then I've got another cube, which is where the sound's going to play, and we're going to block the sound via this wall. So essentially when the player's here, you'll hear the sound full, and when you're here, you won't, because the wall will be in the way. So first things first, I'm going to go to my audio, where the audio source is playing from. I've already got an audio source which is set up with some music I made. So I'm going to go flow machine. I'm going to come over to my flow graphs. I'm going to create a new bolt flow macro, call this audio occlusion. Come back to audio and chuck that on there. Now our flow graph's activated. A quick little shortcut: if you hit shift space when your mouse is over a window, you'll make it full screen. First things first, we want to get the raycast set up. So we want to go add unit, physics, and come down to this one with the layer mask. So this is essentially going to be doing our raycast. So what it's looking for is an origin. So that's essentially where it starts, the direction, that's like where it's going to go, and max distance, how far, and layer mask, which we'll get into later. Essentially, first thing we want to do is we want to get the origin. So that's essentially the position of this object. Get that, plug that in, plug that in there. Then we want to get the direction, and the direction is essentially the best. So next we want to get the direction, and how we get the direction is we want to get the player's position, and we want to get the object of the audio file that's playing, and we want to subtract them. So we'll be using because the objects will be using a vector 3. So when we subtract both vectors, it'll kind of the mass will give us the direction of like where the object is. So first things first, we want to come to the object, and we want to call this object variable player, make this game object, and assign this to the player. So now it's telling our script what the player is. Next we want to get it. So in Bolt, if you drag straight from here, you'll get a variable. If you hold Alt, you'll set. So we've got the player variable now. Now we need to get the position, which is a vector 3. So all we have to do is type get position. Then we can just copy the position of the player. Oops, press the wrong button there. Oops, over here. So we got the position. Then I'm gonna subtract the player position from the audio emitter's position. So chuck that into direction. Next we need to get, now we've got the direction, so the object's going that direction, and something we should do just to help us later is set this as a variable so we can use it. So if you know a bit about C#, you can make local variables, and then that's essentially a variable which exists only within like a function. So this is so if we make this variable, it'll only be, you won't be able to use it outside, it'll only be within here. So we make a flow variable. We want to set flow variable, chuck this up here, and we want to grab the output of this and put that into here, and we're going to call this direction to face. Now if we put that into the direction, that's essentially just doing that and making a variable so we can use it later. So we connect this up. Next thing we want to do is we want to get the max distance, and the best way to get the max distance is to use a C# function called getDistance. So best way to go is vector 3 and distance. To bring this up here, connect there. So we want to Actually, no, sorry. This needs to go here. Like so. Now, to get the distance, we essentially want to get... So what this is going to do is it's going to get distance between A and B. So essentially we just need to get the distance from the object, which is this. And then we need to get the player's position. So we just copy this, pop this here, and that'll give us distance between this object and the player. Then we can put that into our max distance. Now in terms of the layer mask, the layer mask is essentially so in Unity for like objects you have like a layer mask here, and this is kind of like almost like a preset of like what this scene object is going to have. So there's a little window where you can open up, which is I think called the layer matrix or something, and you can set like collisions for these things. So you might be able to set like the water so that like nothing can ever collide with the water, because obviously it's water. So yeah, so ideally what you'd want to do with this is you'd set like all the walls to like structures or whatever, and then anything you make later on your level that's a structure that like this will affect. So for today we don't really need to do that because we just got this little scene. So for this we can just drag out, and we can just say layer mask literal, and we can set this to everything. Alrighty, so that's the raycast setup. Now let's get some flow going. So I'm going to use fixed update because we're using physics. So I'm going to chuck that into the set variable, and that'll go through there. Now, next thing, so this will work now, but we won't actually be able to see. We won't actually be able to see what we've done because it's just like an invisible array. So next thing we want to do is use a debug. So I'm going to write debug draw array. So we just want start, direction, color. So because we made that, so initially we need to get the position again of this object, and because we made the variable here for the direction, we can come right over here and just type get flow variable, click here, direction interface, chuck that in. Now we can make it red, and that's essentially it for the raycast. Now we should be able to come back into the game and hit play. And yep, we can see we now have the raycast between the player and the object. Sweet. Next stage is setting up the collider so we can figure out so we can do something when the raycast hits it. So one thing I've just noticed is that this raycast that I've used here is actually the wrong one. So what I want to use is physics. Come down here, raycast. I want the one which is hit info, this one. So yeah, this one here will just give us a boolean out. So that means that essentially if it hits something, it's going to be true or false. But it's not going to tell us what we actually hit. So this could probably work for some things, but for this I want to know what I hit and get information from that. So I'm just going to get rid of this and bring this one in. And there we go. And we hit play just to make sure it's all still working. Yep, still works. So now we're going to set up the check. So we want to come over to this hit. We're going to get the collider. Get collider. So that's going to give us information on what we've hit. Next I'm going to use compare tag. So next we have to, we want to check, we want to use a tag system to check when we've hit something, when this when this beam has hit something. So I'm going to use the tag of wall. Now, if I come out of here and I go to my wall game object here, I've already got it set to wall, but if you want to, I'll show you how to make this initially. You want to go here, press new one, and you want to type in wall. But I've already got it there, so we don't need to do that. So yeah, once you've set the tag of your object and you set it here, one thing to note is if you do make a new one and you put it here and then you come back, it won't do it for you. You have to come back and then put it here. So yep, I've got the wall set to wall. Now I need to come back to the flow graph. Now we want to go into a branch. So if we hit the wall, this will be true. So the pink ones are essentially booleans, so that's true or false. So if this hits a wall, this is going to go true. Then from then we want to set up the audio mixer. So come out of here, come into audio mixer. I'm just going to drag it up here. I'm going to create a new bus, call this master. Create another bus, call this music. Come over to the audio source, and assign this to music. So now that audio will go here. Next thing, we need to add the low pass to the bus that we want it to affect. So we could put it on the master and everything could, but if you had this set up practically, you might have that only like sound effects or certain effects can be affected by the audio occlusion, so you'd put the low pass on that bus. So I can put a low pass here. Then we need to, so this here will change our frequency that we cut off. So it's a low pass, it'll cut off all the high frequencies. So if we set it here, it won't do anything because it's not cutting off anything. So that's the default value we want to set. Now, if we want to access this through Bolt or through a script, we need to expose it. So we need to come here, right click on any one of these parameters and go expose. That'll put a little expose parameter up here. Now we can rename it and call this low pass. Now if we come back to the flow graph, we need to tell the flow graph what the actual like where that is. So we need to come to object and we want to make a mixer variable and call and search for mixer, audio mixer. Click here, go master. So now we can get the audio mixer and we want to look for set float and come down to audio mixer. So this will essentially give us the ability to access that low pass. So the string is the name of the parameter we made. Now once we've done that, we want to set the value. So the value would be how much we want a low pass. So when we're true, when we've hit something, we want to set that low pass to say, so 5,000 hertz is pretty good, but if we want to get something just so we can really hear it, probably 2,000 is pretty good. Grab that, come back in here, chuck that into value. So when we're true, we're gonna put the low pass on this low pass, and then when we're false, we're gonna set it back to default, which is this. And yep, so that's essentially it. One thing, so if we did this now and we set this up, it would work. But one thing I found is that if you're ever checking for something in with logic like this, so what will happen is like this will hit something and then that'll be fine. But if it doesn't hit something and it's looking for all this stuff and it doesn't find it, essentially the engine will throw an error and be like, well, you said that you're like us, you're looking for this, but it's not here, and it gets confused. Like if it doesn't know where something is, it'll like throw up an error. So yeah, we're looking for something, a collider, and then we're comparing a tag. But if we don't get that, the engine's gonna go, what? Like, what? Where is it? Like, so the best thing we need to do, so to do this, we can do fix this. We can do a null check. So just type here null check. Now we want to null check the collider first before we've hit the to check if the collider's actually hit something, and then if collider has hit something, so that means that we will be not null. Null essentially means like nothing's hit, like it's invalid, nothing's happened with it. So if we do not null, so that means that it has hit something, then we'll do the branch. And a branch is essentially just, if you know like coding, it's just the if statement. If the condition, which is this, is true, do this. If it's false, do that. So the false is essentially just like an else statement in an if statement. So yep, now I've got the wall tag, got all this. So this is pretty much set up to go. If we now jump back into the game, we hit play. You can see the flow at the top. Just got a little error there. Just gonna check that out. Tag wall is not defined. Oh, I think I've messed up something with my spelling. No? Alrighty, so I figured out what was wrong with the setup, and essentially I made a little boo-boo, which is a little simple mistake, which is kind of something you need to keep note of. So I had my wall tag here, had a space there. So in coding, a space is actually something, and to the computer that's wall and space, and I had the tag of wall with no space, so it's like, what the hell, there's no tag. So if you have a similar problem, yeah, don't I have a habit of pressing space after every time I type something, so don't do that habit. So yep, so that's now wall. If we come back to here and we hit play, we're not getting any errors. Come over here, you'll see in the flow graph up the top, so we're setting the float now currently because the raycast is obscured. Now if we come out here, it'll set float to the default value, and you can hear it's slightly muffled there. Come here, we can hear the bass and the kind of rain sounds a bit more. Come here, that's all kind of very muffled. Over here. So that's something a little extra. I just wanted to show what this looks like in a C# script, like, because essentially I made this first on the C# script and then I did it with Bolt. So this is like the script I came up with initially, which I used Fmod for, which is, if you don't know, is just an audio middleware software for Unity and Unreal Engine, and it just essentially makes it a bit quicker to do some things. So if we come down to this part of it, which is the occlusion part, this part here is essentially that raycast node that we used. And cool thing with C#, it actually helps you out a lot. As soon as you type in a function, you put the brackets and you hover your mouse over here, it'll tell you exactly what you need to input. Essentially, it's essentially what Bolt does as well. It's just a little bit less visual. So if we come here, it's asking for a vector-free origin, so that's the position of the object, and then the direction, and then it wants a direction. So here we've done the same as we did in Volt. We got a vector3, so we got the player position, and then we minus the object's position. So that gave us a vector3, which we then inputted into this part of the raycast, which is the direction. Then we've got the hit info, which is here, which on the C# script I outputted this to an actual variable, which meant I could use it later in this if statement. But for the bolt flow, it's not really, I didn't think it was very necessary to do that. You could make it a variable if you wanted to, but it works without it. Next, we've got the distance, which is a max distance. So again, with the C#, we did the same as with bolt. We just got a float distance, and we use the vector3 distance node, which here is asking it's the same thing. Essentially, bolt is just C#. It's all of this, but just condensed into visual nodes. So yeah, we've got the transform position, so that's the position of this object, and the player position, and that gives us the distance, and we put that into the distance of the raycast. And then we've got the layer mask, and the layer mask, I've done the same thing. I've just made a layer mask. This is a private variable, but it's serialized, so it'll show up in the inspector, so I can change it in the inspector. Then the draw array is the same, just transform position, direction to face, and the color red. So, and then to do the low pass, I've essentially used this hit variable, and then checked if the colliders hit something. So that's quite similar to what we've done on the bolt. We got the collider, checked if it's hit something with the compare tag. Here's the compare tag part, so it's just essentially if hit.collider GameObject.tag equals wall. Then we're gonna set the a parameter. So this is what it looks like with fmod. But if you're gonna do this with the mixer, essentially you would just make public mixer, audio mixer. Just call it mixer. And then you'd set that in the inspector. Essentially the same with bolt, and then you come here and you'd write mixer.setFloat string. So we'd put low pass in, and then we'd set it to whatever value we want it to be. So it was like 22,000 or something. One thing I advise if you're trying to learn all this C# stuff is to not copy paste, to just type it again and again, because that's pretty much the easiest way to learn, to get to remember how to type these things. So yeah, we can do that, and we can put in the default, which is this, and what we want to set it to is this. And we want a little f on the end, essentially means it's a float, which a float is just a decimal value. So yeah, that'll work the same. That's essentially the little node we made, which was the set float value, but just in C# format. And we're just triggering it up here on the void update. Here I've just done a little extra thing, which I might have to show you how to do in Bolt, which uses a gizmo so that the raycast doesn't actually trigger unless you're within a certain distance of the sound playing, which I think just works better for performance, so there's not just like a raycast shooting off all the time. So yeah, that's essentially how it looks in C#. And the last thing I wanted to show, just a bit of tidying up. So what you can end up, the Bolt's great, but you kind of end up with this spaghetti scope with this stuff going everywhere. And if you showed this to someone who like didn't know what you did, like it would take a long time for them to figure out how to like what you've actually done. So in Bolt we can create things called comments. So what we'll do is we'll grab this part here and we'll hold control and we'll drag here, and we'll give this the name of direction to face. So now we know that this is for. You can also grab this and just move it around real nice. I'm just going to organize this and just show like what you can do. So I'll probably just speed it up. So yeah, that's nice, looks much neater now. You can easily see all the different parts. Here's our direction face, max distance, here's the raycast, debug, tag check, low pass. Someone who hasn't made this can easily look at this. You can even get even more detail, like these, you can set colors for these. So we could set this one to red for the raycast. we could come in, debug, I don't know, set this green or whatever. And low pass, we can make this like orange. So yeah, this has been a tutorial on how to make a audio occlusion setup with Bolt. I'm hoping to do more videos like this showing how to do audio in Unity with Bolt and also C#, and maybe even a bit of Unreal Engine sometimes. I want to use the Bolt as the Bolt visual scripting is like a way to get people more interested in game audio and like kind of reduce the barrier of entry. As like I find some people that I talk to try to get into this, they kind of hit a wall with the C#, and I think being able to see it visually like this just really helps with learning, but also and just like further understanding. Like I find myself like some parts of C# I've been a bit confused about how the things work, and then seeing it visually here and seeing the flow and everything, saying, oh, so this is actually what this is doing that I've typed here, like this is how it's working. So yeah, I think Bolt's a great learning tool, and Unity's planning to make it a built-in feature of Unity, so it's probably a good idea to learn this because it's probably going to become quite a big part of the workflow of using Unity. Also, please like the video and subscribe if you want to see more, all that YouTube stuff, and comment down in the description if there's something you found trouble with. Like I'll reply right away and try and like help you to get it working. But yeah, anyway, have a good one.